Today we'll prove the trigonometric identity. 1 plus tangent of negative theta equals secant squared of theta. Let's break this down step by step, exploring the properties of tangent and secant functions along the way. Let's start by recalling what tangent of negative theta means. On the unit circle, when we negate an angle, we reflect the point across the x-axis. Remember that tangent is defined as sine over cosine. When we negate an angle, sine changes sign, but cosine remains the same. Therefore, tangent of negative theta equals negative tangent of theta. Now let's substitute this back into our original identity. 1 plus tangent of negative theta becomes 1 minus tangent of theta. Next, recall that secant squared theta equals 1 plus tangent squared theta. Let's understand why secant squared equals 1 plus tangent squared geometrically. In a right triangle, secant theta is the hypotenuse divided by the adjacent side. By the Pythagorean theorem, we know that the square of the hypotenuse equals the sum of squares of the other two sides. When we divide everything by the square of the adjacent side, we get secant squared equals 1 plus tangent squared. Now we can complete our proof. We started with 1 plus tangent of negative theta equals secant squared theta. We showed that tangent of negative theta equals negative tangent theta, giving us 1 minus tangent theta. We know that secant squared equals 1 plus tangent squared. Therefore, 1 minus tangent theta must equal 1 plus tangent squared theta. And this is indeed true, completing our proof. And that completes our proof of this trigonometric identity. Remember the key insights: the behavior of tangent under negation and the fundamental relationship between secant and tangent.